Welcome. In this video I'm going to show you how you can determine Cohen's age with R and the stikpetR library. If you don't want to use the stikpetR library, there's a separate video on how you can also obtain this value. This value is sometimes used as an effect size measure for a one sample binomial or a one sample proportion test. This video will focus on how to obtain the value, not so much if you should be using this, and also not so much on the interpretation. I'm using Jupyter Lab and R version 4.3 in there. The code should also run in, for example, RStudio. I'll leave a link to this Jupyter notebook in the description below. So Cohen's age for one sample is with the apostrophe, which is slightly different than the regular Cohen's age. For the regular Cohen's age, there are some rules of thumb from Cohen, and luckily we can actually convert one sample version to a regular version. To show you how all of this can be done with the library, first load in an example, student statistics data, and the field that I'm going to be using is gender. And in this survey there were only males and females, and it appears that there are more males than females, and this was actually also significant that I already noticed with a one sample binomial test. A separate video available on that. To get the Cohen's age, I need the library. Now the library is available not from CRAN, so you will need to install it using this command that is from my GitHub account. And once you've done that, you can simply load it like any other library. The function Cohen HOS, one sample, and ES for effect size, only has two parameters, data and codes. The data speaks for itself. The codes is the two categories that you want to compare. So perhaps you have a data that has more than two categories, then you can with code select the two that you want to compare. Use a question mark in order to see some more info on this. Let's see how it works. And in this case it's computed to be about 0.50. Now we can convert this to a regular Cohen's age using the ES_convert function from FR from Cohen's HOS to Cohen's age, and then we can use the rules of thumb that Cohen provided by the TH_Cohen age function, and apparently this can be classified as median. These rules of thumb depend on the field you're working in, so you might want to check if these are also applicable for you. Now in the Jupyter notebook I also show some the other library from Power that can actually do the same thing, or just do it all step by step. That's all in the other video. These were the references I've used, and I hope this was helpful. Thank you for watching.